Good morning, children. Today we have to learn the new topic, probability, that is chapter 16. It's the last chapter, chapter 16, probability. So already you know how to find the probability of an event. Probability of an event is equal to number of favorable outcomes by total number of equally likely outcomes. Smaller classes you have studied. So this theory is known as classical approach of probability. Classical approach of probability. And also in 9th standard you have studied how to find the probability using the observations or collected data. That is statistical approach of probability. But these theories have some defects. That is, for the experiment which have infinite number of outcomes, then these theories are not applicable. And also in classical approach we assume that the outcomes are equally likely. Equally likely means equal chances to occur. When we throw a coin, when we throw a die, the outcomes are, when we throw a die we get 1 to 6 numbers, and we suppose that they are equally likely, equal chances to get 1 or 2 or 3, like that. In the same way for coin, when we throw a coin, when we toss a coin, we get either head or tail. Then we assume that equal chances to occur, they are equally likely. So this is not, these two theories are not logically correct definition. So mathematicians developed another theory, that is axiomatic approach of probability. So in this chapter we have to learn that. Before that we have to revise the basic concepts of probability. That is the first one, random experiment. What is random experiment? An experiment is said to be a random experiment if it satisfies the two conditions. The two conditions are, it has more than one possible outcome and it is not possible to predict the outcome in advance. For example, rolling a die, tossing a coin. When we roll a die, what are the possible outcomes? Possible outcomes are 1, 2, 3, 4, 5, 6. And what do you mean by outcome? A possible result of a random experiment, that is called outcome or sample point. Then set of all outcomes, set of all possible outcomes, that is known as sample space, and it is denoted by the letter capital S. So for rolling a die, the sample space S is equal to set. Sample space is a set of all possible outcomes. So set 1, 2, 3, 4, 5, 6. When we toss a coin, the sample space S is equal to H, comma T. Okay. So the first exercise based on the sample space. Describe the sample space for the experiment. A die is thrown 2 times. A die is thrown 2 times. So sample space S is equal to, when it is 1 time, 1, 2, 3, 4, 5, 6. When it is 2 times, it is ordered pair 1, 1. Okay. Then we can write 1, 2, 1, 3, all possible outcomes. 1, 4, 1, 5, 1, 6. Then as in the second row we can write starting with 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Then 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Then 4, 1, 4, 2, 4, 3, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 6. Then last row 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So total how many outcomes? 36 outcomes. When we roll a die, there are 6 outcomes. When we roll a die 2 times, there are 36 outcomes. Then a coin is tossed 2 times. A coin is tossed 1 time means H or T. Here 2 times. So sample space S is equal to set of all possible outcomes, we get either HH, head, head, and look children, head then head, but no need to put this comma, you can write together. It means the first head, the second chance also head, then put a comma. The next possibility, head tail, the next tail head, then tail tail. That's enough. Bracket also no need, just write as element separate by commas. Now what about a coin is tossed 3 times? 3 times sample space, triple H. Write in an order. So triple H, then double H and 1 T, then HTH, THH. Write all the possibilities with 2H and 1 T, then H double T, THT, TTH, then 3 T's. How many outcomes? 8 outcomes. Now here a coin is tossed 4 times. So 4 times H, 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 H. 4H, then 3H and 1 T. So at first T is in the last position, then change the position of T, H, T, H, H, then T, H, H, H. Okay, so that finished. Now double H and double T. Okay, then change the positions, double T, double H, or H, T, T, H, T, H, H, T, then T, H, T, H, or H, T, H, T. So 1, 2, 3, 4, 5, 6. 6 outcomes with 2H and 2T. 4 outcomes with 3H and 1T. Then now H and triple T. So T, H, T, T, or T, T, H, T, then T, 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 H. Okay, and the last is 4. Total you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So when we toss a coin 1 time, 2 outcomes, 2 times 4 outcomes, 3 times 8 outcomes, 4 times 16 outcomes. Okay, so 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, in that way. That die, in the case of die also, 1 times 6 outcomes, 2 times 36 outcomes, 3 times 216 outcomes, like that it goes on. Next is, a coin is tossed and then a die is rolled only in case a head is shown on the coin. So a coin is tossed means either we get H or T. Then a die is rolled only in case head is shown on the coin. So when we get head, then next what we do when we roll a die. So we get H1, this is one possible case, or H with the number 2, or H with 3, H with 4, H5, H6. Clear the experiment. First we toss a coin. So toss a coin means either we get head or tail. Then if we get head, the next we roll a die. So for this H you have to write H1, H2 up to H6. And the other possibility is tail. And if we get tail, we don't do anything, that's tail itself. Okay. So this is the sample space, total 7 outcomes. A box contains 1 red and 3 identical white balls. 2 balls are drawn at random in succession without replacement. So in a box, 1 red is capital R, and 3 white balls. 3 white balls, they are identical. So don't give the numbers W1, W2, W3. If they are not identical, you have to specify W1, W2, W3. Otherwise, just W, that's enough. So in a box there are 4 balls, 1 red and 3 white balls. Then we are taking 2 balls at random without replacement. So taking 2 balls, what are the possibilities? Possible outcomes. Set of all possible outcomes, that is the sample space, that's equal to set. What are the possibilities? Either I will get red, the second chance white. You are taking 2. So red and white, one possibility. Or the first is W, then red. Okay. Then W, W. Only 3 possibilities. This is sample space. Next one. An experiment consists of tossing a coin, then throwing it second time if a head occurs. If a tail occurs on the first toss, then a die is rolled once. Once again read the experiment. Tossing a coin. First we are doing tossing a coin. So either we get head or tail. If head occurs, what we do? Throwing it second time if head occurs. Okay. If tail occurs, a die is rolled. Got it? So H. If head occurs, what we do? Again we toss a coin. Again we toss a coin means again we get H or we get tail. So only 2 possibilities. Is it okay? When we toss a coin, we get either head or tail. When head occurs, we toss the coin again. So HH, HT. And if in the first case we get tail, what we do? A die is rolled. So T1, T2, T3 up to T6. This is sample space. 6 plus 2, 8 outcomes. A coin is tossed. If the outcome is head, a die is thrown. If the die shows up an even number, the die is thrown again. So here again a coin is tossed. A coin is tossed means head or tail. If head occurs, outcome is head, a die is thrown. Okay. So H and T we get. If head, what we do? Roll a die. So H1, H2, H3 like that, H6 we get. Then if the die shows up an even number, then die is thrown again. So for this H2, H6 and H4, the die shows even number. So again you have to roll a die. Okay. So we can write H1. We can stop there, H1, then H3, H5. Okay. If it is H2, again die is thrown again. So H21, H22, H23 like that, H26. Then the same case for 4 also. H41, H42, etc., etc., H46, then H61, H62, H66. Then what about tail? Nothing is mentioned in the question. If head occurs, we roll a die. If the die shows up an even number, again you have to roll a die. So this is the experiment. So here 6, 6, 6, 18, 18 plus 4, 22 outcomes. Next one. The numbers 1, 2, 3 and 4 are written separately on 4 slips of paper. The slips are put in a box and mixed thoroughly. A person drawn 2 slips from the box one after the other without replacement. And what is the sample space of this experiment? It's a random experiment. Random experiment means we can't predict outcome in advance and there are more than one possible outcomes. So what is the sample space of this particular experiment? We have numbers 1, 2, 3, 4. Numbers are written on 4 slips of paper and we are taking how many slips? 2 slips. So what are the possibilities without replacement? So we won't get 1, 1. There is no possibility since there is only 1 here, and without replacement we have to take 2 at a time. So is 1, 2 is one possible case. I can take the slip 1 and 2, or the other case is 1, 3 or 1, 4. 1, 1 is not possible. Okay. Now 2, 1, one possibility, 2, 2 not possible, 2, 3 and 2, 4. If it is with replacement, then we can write 2, 2. Then with 3, 3, 1, 3, 2, 3, 3 is not there, 3, 4. Then 4, 1, 4, 2, 4, 3. Okay, so 3 into 4, 12 outcomes. A coin is tossed. If it shows a tail, we draw a ball from a box which contains 2 red and 3 black balls. If it shows head, we throw a die. So a coin is tossed. A coin is tossed means either we get head or tail. If it shows head, we throw a die. So H1, H2, H3 up to H6. And if it shows tail, what we do? We draw a ball from a box which contains 2 red and here not identical balls. So you have to give the number 2 red balls, R1 and R2 and 3 black. So B1, B2, B3. Okay, so in a box there are 5 balls. If we get tail, we have to take 2 balls. No, only 1 ball. 1 ball from the box which contains 5 balls. Okay, so T with either red or white. And we are giving numbers, so you have to specify that. So the one possibility is TR1, first red ball or second red ball, or black, first black, second black, third black. Okay, here the balls are not identical, that's why we give the numbers. Otherwise just you can write R and B. So here TR and TB, that's only the cases, but here balls are not identical. So 5 possibilities are there. A die is thrown repeatedly until a 6 comes up. Okay, a die is thrown and we stop only when we get a 6. So maybe 6 in the first chance. When we throw a die, and first time itself sometimes we get 6. So we can stop. Or 6 in the second chance. Second chance means first number 1, then 6. Okay, 1, 6. Or 2, 6. Or 3, 6. 4, 6. Lot of commas now. Can I put bracket? 1, 6. Or 2, 6. 3, 6. 4, 6. 5, 6. 6, 6 is not possible. When we get 6, we have to stop. Okay. Now here 6 obtained in the second trial. Maybe 6 obtained in the third trial. So how to write 1, 1, 6 or 1, 2, 6, 1, 3, 6 like that, 1, 5, 6. then 2, 1, 6, 2, 2, 6, like that. It goes on. That means the sample space is an infinite set. It won't stop. Okay, when we get 6, that time only you have to stop. So it's an infinite set. The first case is 6 in the first trial. This much is 6 obtained in the second trial, then third trial, then maybe in the fourth trial, fifth trial, like that. So it's an infinite set. The last one. An experiment consists of rolling a die, then tossing a coin once if the number on the die is even. So here rolling a die, that's experiment, rolling a die. When we get the number on the die is even, then tossing a coin. When the number on the die is odd, coin is tossed twice. So S is equal to rolling a die. So we get 1, 2, 3, 4, 5, 6. Okay, the number is even means tossing a coin once. So I am writing, if it is 2, 2 is an even number, then tossing a coin once. So 2H, 2T, like that. 4H, 4T, 6H, 6T. Now what happened in the case of odd number? When die is odd, the number on the die is odd, the coin is tossed twice. So coin twice means HH, 1 HH, 1 HT, 1 TH and 1 TT. The same way you have to write 3 HH, 3 HT, 3 TH, 3 TT, then 5 HH, 5 HT, 5 TH and 5 TT.